Okay, continuing on from yesterday, thanks for all the suggestions on yesterday's question. The answer was that I was giving the pulses to the servos too quickly, so that was the main problem. And the reason I was doing that was because I basically just kind of forgot about how it was being done by the YMFC source code. And the way it does it, this is in the main loop here, it basically just waits until 4 milliseconds has passed from the last time it sent the ESC pulses. Originally it was all ESCs, so this was for a quadcopter flight controller, and ESCs can handle a 250 hertz PWM pulse just fine. And I guess also those first servos that I was using, they could handle that as well. But these slightly cheaper servos that I was using in this wing, they needed a slower one, so I set it to do... Originally this right PWM was just immediately here, and that would be the end of it. But now what I'm doing is I'm incrementing a counter, and only every 5th time will I write the PWM. So instead of a 250 hertz pulse, we have a 50 hertz pulse. So this is going to be 20 milliseconds between each pulse, which is perfectly fine for these servos, it seems. So that's great. The other problem that I seemed to be having was that there was a bit of a bad connection, so I've tidied everything up, made it a little bit more tidy. It's kind of hard to... the best way to hold this, I can't actually see my computer screen now to see what you can see. But you may be able to see that right on the top of the ATmega chip there's a bit of double-sided tape residue, because that's where I had stuck the gyro to begin with. And I think it may have been partially to do with that. Perhaps this tape is a little bit conductive, because now I've stuck that on the front on top of the receiver instead, and that's helping. And also I've soldered down these connections, so they're no longer just a DuPont connector stuck on there. They're actually soldered to make them much more secure, and not having any more problems now. So I can't really show you very well how it works, but just as a very quick demo, I also put in a 2-second delay, because you need to let it sit still at the beginning, and I might still be plugging in the plug. So I added a 2-second delay to make absolutely sure it's going to be sitting still when it does the gyro calibration. So now you should see, well, you can't really see very well I suppose, but you can probably hear that the servos are moving a little bit. Not much actually. And if I turn my radio on, so it's all good, and all of the directions are correct, and I adjusted the gyro directions so that the corrections that the gyro causes will be the correct direction as well. Oh, that's interesting. Oh, I see, yeah. So I'm going to do some tuning now, and I'll show you my setup that I have to do this out in the garage after this. But what I've done at the moment is I'm using these 2 dials, so I have channels 5 and 6 on these dials, and I'm using that to scale how much correction the gyro is going to cause. When the dial is like that, that's 0 for both of them. So they should be doing nothing now. I'm not sure why they were moving just before I turned the radio on. That's interesting. But anyway, in this situation they should be doing nothing. And if I turn this dial all the way full, this should give us full roll stabilization. Just put this down. So pitch, it doesn't do much. In roll though, we have full roll stabilization active, and it's probably really hard to see that, but it is going in the right direction, I think. And then This one will be pitch stabilization, so if I turn that to full and that one to 0, we should only be hearing corrections when we change the pitch. Well, yeah, mostly. So I can scale these to, say, maybe halfway to start, and depending on how effective or ineffectual the result is, I can change the dial a little bit, and then I'll have to connect it up to the computer again to read out or to print out these values to see exactly what they're set to, and then I can hard code them, and then I might put the gyro stabilization activation on a switch instead, so I can compare as I'm flying what the difference is like. So now we're at halfway on both of them. Right, I think we are good to go. So let's take it out to the wind tunnel and give it a try. Okay, so I was going to show you how my cool wind tunnel works, but I might have to just show you how it doesn't work, because I gave it a little try now and it doesn't really work very well. At least it's having some effect on the movement of the plane. So it consists of an upside down quadcopter with 10-inch props, and we can spin that with this transmitter. So around about a little above half throttle seems to be enough to have a decent reaction here. So everything's on full, and it doesn't really make much difference whether it's on or not. It may be that in actual flight, when you're flying around, it might be able to tell a little bit more difference, but I think one of the problems could be that when I'm going to the right, let's look at this one. When I'm going to the right, what? Oh. Yeah, the ailerons don't move as much as when I'm going to the left. So I might have to, I might just completely replace this. I bought some balsa wood to replace these ailerons with, because the joints are really crappy, these foam models. I was really surprised when I first saw how they make them. It's just a pressed thin piece in there that's, it's almost guaranteed to break on the first couple of crashes, isn't it? At least that's what I've found with this plane, and the big plane I have too. It just breaks along here straight away. So I might try changing this to balsa wood and duct tape or cloth tape hinge. Yeah, so maybe this is in the wrong place on one of these. I don't think I've changed anything though. But it just does seem that it's really, it hardly moves that way. And it goes a long way this way. And we'll be able to see that when I turn this on, that we can't actually... See, the other thing is we've got a little bit of wind coming in here, which kind of messes things up. Anyway, let's give it a try. So I'll turn the stabilization right off to begin with. Not that it makes much difference. So I'm not touching anything. I can't. It's not bad already, right? Oh, okay. Anyway, now turn the roll stabilization up. Maybe just slightly better. Can't turn. So that's pitch. So now I've turned them both all the way up, but you will of course realize that pitch stabilization is not going to do much for us because we're sort of restricted in the pitch axis here by this point being held. So this sort of test is not going to do much for pitch stabilization. Yeah, I don't know, doesn't seem to be doing a hell of a great job, but I think I'll give it a fly now and just turn them both all the way up and see if I can tell any difference when I'm flying to them being all the way up or all the way down. I guess the other problem, perhaps, is that since this is not a proper tunnel, and we have 4 propellers, it could be that there are slight areas here where there's less air pressure coming down than in this next area. So maybe we need more distance and we need to constrain the air properly so that it's actually a tunnel. Wouldn't you know it? But anyway, that's going to do it for this. It was worth a try, I think, but the actual result when it is really flying is probably going to be more important. So let's give that a shot. Oh, it's getting cold. Okay. Let's see how this goes. There's almost no wind, which is nice, I guess. So actually it seems to be coming from that way. See what happens. Actually, I'll throw it this way. Ooh. Not a good start. At least the grass is nice and long here. Oh, it's not bad. Shit, it's not bad. I can feel it, I can see it fluttering, which I'm not doing. So maybe that's a little bit of an overcorrection. Oh, it's definitely an improvement. I'm quite happy. Yeah, it's sort of fluttering. Oh, that ain't too bad at all though. Yeah, it's see that? So what we could do, that was pitch, wasn't it? So pitch is on, they're both on full at the moment. I'll turn it down to a little bit over halfway. But that was actually pretty good. It reminded me, you know what it reminded me of? It reminded me of the first time I flew this on a very, very calm day before I broke the ailerons. And it was nice and smooth and very controllable. That's what it feels like. So, yeah, this is a step forward. I'm quite pleased. Let's see if we can do that again. Well, it's still fluttering. It only seems to flutter when I give it lots of throttle though. So I wonder if that could have something to do with the motor. Vibrations from the motor are the problem. Oh yeah, this is really quite nice. Mind you, it's been a while since I flew it with no wind, so that could be contributing. Let's give it a high throttle again. Oh yeah, not bad. This is nice. Alright, so yeah, high. When you give it a high throttle, it still wobbles like this. But it doesn't go out of control. It sort of just flutters and looks a bit shaky. Oh, this is great. It really does feel like that first day that I had it. Oh, I'm glad this was worth it because I put quite a bit of time into it. Would have been annoying just to be, you know, making it worse. I think I could turn the roll stabilization down a bit too. That was supposed to be a landing. Let's try again. Okay, so roll can go down to just over halfway too, I think. Maybe pitch. Put them both to about halfway maybe. Okay, so they're both slightly over halfway. This is fun. Oh. Oh shit. You know what? It's not as stable now. That was too much of a decrease in... Oh, bloody hell. Okay, roll. Roll is going back up to about 3/4. Where's full? That's full. Okay, so roll can stay at 3/4. Interesting. Well, that was nice, because now that I know that if I reduce the stabilization a bit, I actually get worse performance. So it's not just a matter of there being no wind today, which is making it pleasant to fly. It is actually the stabilization that's helping. Yeah. Dive. Oops. A bit too much. Still flutters at high throttle. Oops. Lovely. Here's some onboard video. You can see a little bit of vertical flutter right at the beginning as I give it some throttle to take off. But other than that, you can't really see much flutter in this particular flight. I actually recorded some commentary as I was doing this with my hat cam, but this stupid RunCam HD stopped recording after about 10 seconds, as it likes to do. So yeah, I can't really remember what I was saying at the time. And this flight did not last very long anyway, just a couple of minutes. So I'll just let this play out, but you'll see at the end of the video, basically it seems like the Arduino crashed or the program stopped running. Not really sure why, and I don't think I'll be in a hurry to fly this again until I can figure out what it is, but I have a bunch of other things that I'm kind of interested to do, so I'll just leave this as a puzzle for now, and I'm really at a loss as to what the problem might be, because I've checked pretty much everything I can think of. All the connections seem to be pretty good at the moment. Yeah, not really sure what it could be, because that first flight went very well. The only difference is that the plane is carrying a bit more weight now, so I guess it needed higher throttle to keep flying, and maybe something to do with that caused the BEC and the ESC to not be able to provide enough power for the servos, which then maybe that caused the Arduino to reset or something. I don't know, but I think overall though this was a fairly successful little project, and I hope it was interesting to watch. So thanks for watching.